We have a very good example here. A reacting with B to give us C and D. If you look at that case there are two arrows pointing opposite directions. When two arrows are used pointing opposite directions in chemical reactions, depict a reversible reaction. The arrow that points from left to right indicates the forward reaction. So this one is indicating the forward reaction, a reaction that leads to production of C and D. The arrow that is pointing from right to left indicates the backward reaction, which now means in this case, it is like we have two chemical reactions in one. How? Look at this. It's now the forward reaction. Then we now have another chemical reaction whereby now CD reacting to give us AB. So that is the scenario. And that is why I'm saying in this case, in reversible reactions, we have two reactions in one. These two chemical reactions, they take place simultaneously in opposite directions. So when immediately the reaction starts, A and B will first of all form C and D. And when there is available C and D on the product side, then the backward reaction would start. And when it starts now, the two opposite reactions will proceed simultaneously and they never reach completion. So unlike irreversible reactions never reach completion. They can continue indefinitely because at any given moment, there will be reactants on either sides. That is a diagram that shows the interconversion of the states of matter. And in this case, we are talking about water. So the process A, we know that one is melting. Then the process B, we know this one is freezing or solidification. Then the process C, this one, we know this is evaporation. Then D is condensation. We call this process F sublimation. Then this reverse, the reverse of sublimation is deposition. So that diagram shows that states of matter are examples of reversible physical changes. When we talk about a physical change does not have any impact on the composition, the chemical composition of a compound. Now, for example, the chemical composition of water in solid state will still be H2O. In liquid state, it will still be H2O. In gaseous state, it will still be H2O. So there is no any change in the chemical composition of the substances. So these reversible physical changes will also involve change in color of compounds or change in color of substances. And remember, these physical changes will only occur when there is change in temperature. Either you raise the temperature or you lower the temperature, then you will be able to make observations. Color changes of compounds or substances are another example of a reversible physical change. And as I have said, the changes will occur due to it changes. So I want you to look at this particular example here. So this is another example of a reversible physical change. Lead 2 oxide is yellow when cold, but when you subject lead 2 oxide to temperature rise, the color now changes from yellow to orange. So that is an example of a reversible physical change. So the forward reaction, we are subjecting the reactant to temperature rise. Then the backward reaction, we are subjecting the substance to low temperature. That is why we will have now this change. Number 3, iodine is an halogen that will exist in the solid state at room temperature. And we know the color of iodine is gray, dark gray, crystalline solid. But when this iodine is heated, it sublimes. It is bypasses the liquid state and then forms iodine in gaseous state. So remember that process is the one that we are calling sublimation, where a solid bypasses the liquid state when heated. When iodine sublimes, the color will now change from dark gray to a purple vapor. That process can also be reversed, whereby you now subject the iodine vapor to low temperatures, where it will now get deposited to give us iodine solid in crystalline form. The forward reaction is sublimation. Then the backward reaction is deposition. Example number 4, which is also an example of a reversible physical change. And that is carbon 4 oxide. We have carbon 4 oxide that is in solid state, and then we have carbon 4 oxide that is in gaseous state. This one, if it is cooled at a very low temperature, it will give us carbon 4 oxide solid. Remember now, that one is deposition, changing from gaseous state to solid state directly. Then we can reverse that process by heating the solid carbon 4 oxide.